All right, so we pick up on section 5.4 on the second page here, and we have some graphs of exponentials in their inverse logs. Okay, what I want to look at though is this inverse properties. If f of x equals log base a of x and f inverse of x equals a to the x, then they're inverses, and either one could be f and f inverse. Find f of f inverse of x and f inverse of f of x. Okay, so let's see what we can do with that. So f of f inverse of x, let's do some color coding in green. F inverse of x would be f of, and f inverse of x is a to the x, yeah, and f is log base a of whatever the input is. So this would be log base a of a to the x. Okay, all right, and that's as far as I can go. What else can I do with this? Well, the only thing I know is that f of f inverse of x should be x. Okay, so this should be x. So log base a of a to the x is x. Notice it's the same base, right? Log base a to the x, the base is a. And notice you're applying a logarithm and then an exponential, or an exponential and then a logarithm with the same base, and so what you're doing is you're applying f and f inverse, and that should give you x. So log base a of a to the x is x. Notice that if we think about what we just did on the previous video, a to the x equals a to the x. All right, let's do f inverse of f of x. F inverse of f of x would be f inverse of, and f of x is log base a of x. All right, and f inverse is a to the whatever the input is, right? F inverse is a to whatever the input is. So this would be a2, and the input is log base a of x. So this is a to the log base a of x, and of course f inverse of f should also be x. Okay, so this gives us some ways of simplifying. So whenever we see log base a of a to the whatever power, that's the answer, the power. And whenever we see a to the log base a of any x, the answer is x, right? So 2 to the log base 2 of x is x. 5 to the log base 5 of x is x, right? Or 5 to the log base 5 of 0.6 is 0.6, right? 2 to the log base 2 of 0.6 is 0.6. Same thing here. Log base a of a to the 0.6 is 0.6. Okay. Log base a of a to the 7th is 7, right? Etc. Etc. All right. Let's try some of these examples. So log base 3 of 3 to the 12th should be 12, right? Log base 4 of 1 over 64, well, 1 over 64 is 4 to the negative third, so I can think of this as log base 4 of 4 to the negative third, and that should be just the negative 3. Notice that makes it a little bit easier for us to work it out, okay? ln of e to the negative 8, this says, because ln is base e, right? Log base e of e to the negative 8 is negative 8, okay? All right. And I'm going to leave the rest of them for you. These, D, E, and F. All right. Let's proceed to number 5. So number 5 says, find an integer n such that, or so that the logarithm is between n and n plus 1. That's the logarithm right there. Okay. So how do we know what n should be? So this is the way we think of this. We think of powers of, the base is 2. So we think of powers of 2. And you don't have to start with 2 to the first, but I'm going to start with 2 to the first. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. What I'm looking for is whichever one of these numbers is around 13. So notice it's between 8 and 16, right? Between 8 and 16. So log base 2 of 13 is between 3 and 4. Notice this is the exponents, right? Log base 2 of 8 is 3. Log base 2 of 16 is 4. So log base 2 of 13 is between 3 and 4, right? The way we say it is like this. 3, actually, we say n equals 3, right? So the integer n says that the logarithm is between n and n plus 1. So n is 3 and n plus 1 is 4, right? It's between 8 and 16. So we say n equals 3. Okay? But the way you want to think about it is log base 2 of 8 is less than log base 2 of 13, and that's less than log base 2 of 16. Yeah, and log base 2 of 8 is 3, is less than log base 2 of 13, is less than, and log base 2 of 16 is 4. So log base 2 of 13 is between 3 and 4. Okay, but if they ask us this way, find the integer n equals 3. All right, let's do one more, and then I'll let you guys, I'll leave the rest for you. I'll leave B for you guys, and I'll do C. ln e of 13. So ln is base e, remember, so I want to think e to the first is e. E to the second is, let me get my calculator. There's my calculator. My calculator says e to the second is 7.39 about, okay? E to the third, oops. E to the third, my calculator says is 20.1 approximately. So e to the third is about 20.1. And that's way over 13, right? So e to ln of 13 is between 2 and 3, because 13 is between 7.39 and 20. So n equals 2, right? It's the first number, between 2 and 3, so n equals 2. All right, and we'll leave B and D for class. All right, let's do a couple more of these. We're going to leave number 4, that word problem, for class. And we're going to solve some equations. Okay, and we'll leave the number 8, which is just a transformation, right? Shifting left or right, up and down, etc. Oh, I'm sorry, this is F inverse. So graphing the inverse, which we'll leave that for class. All right. So let's solve some of these. How are we going to approach this solving equations? So remember first that log base a of x equals k can be rewritten as a to the k equals x, right? A to the k equals x. Notice how I pointed out in this original equation, a to the k equals x. Also, if a to the k, x equals a to the y, that means x equals y. Okay, that means if you have a base and it's the same base on both sides of the equals, and you have some expression in the power, and the other one looks like it's a different expression, the expressions are really equal to each other. Okay? All right. So let's try the first one. Log base 2 of x equals 3. So I can think of it this way, and I can think of it as 2 to the third equals x. 2 to the third equals x. Notice x equals 8. Don't say 2 to the third, right? That means you're asking me to do the work. And what you want to do is simplify it yourself. Okay? How about 2 to the x equals 8? Well, we can rewrite this as log base 2. Oh, I'm sorry. No, we don't have to rewrite it. We can rewrite it as 2 to the x equals 2 to the third. Right? Notice you want to think of a number with the same base, right? And so if 2 to the x equals 2 to the third, that's this situation over here. X should equal y. So here x should equal 3. Right? Notice it's 2 to the third equals 8. Right? Okay. And let's do the last one. 10 to the x equals 32. So that one I am going to write it in this form. Okay? So this says log of 32 equals x. Remember, the exponent is the answer to the log, right? There's the exponent, it's the unknown. And then what? So we can actually approximate this. So this is an exact answer. X equals log of 32. Okay. Your calculator, though, has a log button. So mine is this orange button right there. And I'm going to type in 32 and take the log of that. It's the orange button. I lost the log. There it is. And I get 1.51 approximately. So x is about 1.51. X is about 1.51. So if somebody asks me for an approximation, I can say 1.51. Now what does that mean? Well, it means, remember, x is the exponent on 10. So 10 to the 1.51 should be 32. And I'm going to do that just to check it. So 10 to the power of 1.51 gives me 32.4, which is about right, because it's not an exact answer, so it won't give me an exact 32. All right, and we'll leave the rest for class. Okay, so we did for number 7 A, B, and C, and we're going to leave D, E, and F, and the very last problem also for class. All right, so that'll be the end of the second video for section 5-4.